Hey, how's everyone doing? We are streaming live. I see William here. I see Morgan here. We got Mewbot here. I think Mewbot's awake. Uh-oh. I hear myself in the background. Hey, Krista, how are you doing? Let me stop the stream. There we go. Good. Stream's working good. Guy, good to see you here. Brooke, good to see you here. We're going to make sure Mewbot's waking up. Gotta wake up Mewbot. We'll get some points after the Kahoot. Good to see you, Anthony. How many people we got here? We had like 17 people vote for the evening, so we should have 17, right? Let's cross our fingers. 10. I'll take 10. Sounds good to me. Everyone's here for their night. Caroline, good to see you. Anthony, Guy, Brooke, Morgan, Krista. We got the music playing in the background. Let's start here in 2 minutes. Sarah, good to see you, Sarah. We'll go for 2 minutes. Maybe we'll see if we're still having people join in. Good evening, Sam and Gabrielle. Good to see you. There we go. There's Mewbot. Mewbot in the background. We've got the code on the screen. So if you don't know, go to kahoot.it. Haley's here. Awesome, Haley. This is going to be a tough competition. We've got 2 prizes. We've got a prize for first prize and a prize for second prize. And I'm going to do a big Kahoot at the end for the last test. I do a $50 Kahoot usually for tests, but since we're like once a week right now, I'm going to do a big Kahoot at the end, a $50 Kahoot. So stay tuned at the end of the semester. So if you're playing these Kahoots, you could win. You could win a $20 for this one, $10 second place. We got Blue Dove in right now. We're going to do a big Kahoot at the end of the semester, so stay tuned for those prizes. At the end, could you help with the Canvas content? Yeah, let's do a Canvas content at the end. You got it, AJ. Definitely. And everybody, great work. I know there's a lot of work. I was replying to a lot of emails. I've got to mark the video for later tonight. I went out and had to go by the UPS store today. So it's like, you go out and you're like, wait, where did the day go? I just went out and do something for like 2 hours. And I'm like, wait, I get back and I'm like, okay, wait. It's so quick. So thank you everybody for all your hard work. I know a bunch of people have already started working on chapter 5. Who like, I want you to put in the chat. We'll get started here in just a moment. But with chapter 5, who's got it completed and how long did it take you to do? So I just want people to know this. Like after this Kahoot tonight, start looking at chapter 5. If you're watching this right now and you haven't looked at chapter 5, start looking at chapter 5. Start asking questions. Start, on Discord. I've been answering a few questions on Discord. Are the questions the Kahoot pulled out? Kind of. There's definitely some that are very related to test questions. Like, let's just say they might be like a reformatting or rewording. With breaks, 1.5 hours, definitely. Pretty long, Morgan says, yep. So it's not something you want to be starting. About 3 hours. There you go. It's a good bit of work. Took me an hour and a half, all because I had to get exactly. Get the hand of it, exactly. Took a minute. Definitely took a minute. So listen to everyone right here. I always want the classmates to give advice to people. Did you move back chapter 6 due tomorrow? I believe so. It should be moved back. And then we move back chapter 8 to Saturday because the exam goes through Saturday now. So just a little more time. This video will be reposted. Or this video is posted. So any video I do live streaming on YouTube, you can watch it anytime after. And you can always pause the video live. Good. Yeah, like get a handle on it, get the hang of it. Exactly. Now, awesome work. I think that's got... Wait, did the timer already go off? I think it's time, everyone. Who's ready to Kahoot? 16 people is really 17 people. Awesome Cheetahs. I mean, with Awesome Cheetah, we got to do this. Puppet Shark, you ready? Puppet Shark, you here, man? Where you at, Puppet Shark? Yeah. Puppet Shark's ready. Puppet Shark's always ready. No worries, Haley. Who's ready right now? Should we wait? Should we wait another 10 minutes? What do you think? Thoughts? I say we wait 10 minutes or we start right now. What do people say? I don't hear any votes. No one's saying anything. Expert Koala would not have made it. AJ says C. Anthony says I'm ready. Looks like one person's ready. Guy's ready. We got a few people ready in the chat here. With that, William says start. Morgan says let's go. We got ready. Let's do this. Here we go. Let's start up some Kahoots. I hear like noises outside. Which of the following phrases helps us identify quantitative variables? So when you think about a quantitative variable, what does Brian always say to check for quantitative variables? Like if I ask you your age, your weight, your height, your GPA, a lot of them you don't say like this phrase, but you'd be basically saying it. Like when I say your GPA, I'm saying like, how much is your GPA? It's kind of weird to say, right? Like how much is your GPA? But what can you do with quantitative variables? If you see something and it's quantitative, Like if I say how many points did people get or how many votes were for this option, what can you do with quantitative things to know that it's actually quantitative? Because the hints, quantitative variables are actual real numeric numbers, like they're actual numeric numbers. So, I mean, that's kind of the answer I was looking for right there. But quantitative variables are real numeric numbers. You can do mathematics on them. So quantitative variables are real numeric numbers. So make sure if you're looking at something and if you want to see if it's quantitative, you can count it. You can, well, so you can count as in, so we wouldn't want to say, you're right, Anthony, but we want to think of things like we can do mathematics on it. Because if we say count, we might be talking about like categorical variables, which, let's see who's in the lead first right here. Joyful octopus. And we've got a lot of close calls right here. Royal giraffe. You know what? I'm going for cute dolphin. Imagine if you owned a cute dolphin. That'd be amazing. That's my favorite right now. Cute dolphin. Let's make this happen. Let's see you win the game here. Cute dolphin. I'm rooting for you. Let's find out who's going to win with this next question. Let's do it. The University of Tennessee uses student ID number, example 239. That's not a full one. What type of variable is this in your database? Student number. Maybe I threw something in the middle there. These are variables that cannot repeat. They can never repeat. That's the key thing for this type of variable type. They cannot, will not ever repeat. No matter how many of these you have, they cannot, will not ever repeat. So an identifier. What's another identifier that you can name? Remember we do that. We got to do it. We got to do it. What are other types of variables? What are other types of identifiers? What are other identifiers? Social security number, license number, your fingerprint, social security number. All of these are identifiers. And why are they identifiers? Because they cannot, they will not ever repeat. They won't stop. They can't stop not repeating. I guess that works. So identifiers, tracking number, exactly. Like we were supposed to get a package today, it didn't come, and I have the tracking number. I'm not going to look it up, and they're going to be like, which one of these tracking numbers is yours if it's the same tracking number? Tracking numbers are unique. They identify the package that you're looking for. So tracking number would be an identifier. DNA, great answer right there, Guy. Excellent work. Let's throw out some points. Mewbot's awake. I heard people mentioning something about quotes. People were talking about the quotes, and they were saying we need to add more. We definitely need, if there's something, people say clip that online, but we need the phrase quote that, because I think it was quote 76 today. Was it quote 76 we just got? So if you ever see a quote or something in chat, and sometimes, you know what, we do allow people sometimes when they win the Kahoot to put in a quote. Or was it quote 72? I can't remember. Mewbot. How many quotes are we at, Mewbot? Yep, it was quote 76. Favorite quarterback, LeBron James. Everyone's favorite quarterback. Let's see. Cute dolphin, you doing all right? Oh, this is Blue Dove is taking down Joyful Octopus. That's like a nosedive right there by Blue Dove to destroy Joyful Octopus. Ooh, it's going to be close. Let's find out. I swear those circles are moving. They are moving. Let's find out who's going to win with the next question. Frozen yogurt. I had frozen yogurt today. Why no? Why? William, I love frozen yogurt. Let's find out, William, who's going to win here. Which of the following phrases helps identify identifier variables? So this is more about identifier variables right here. They're a certain thing. Which of these would help us identify identifiers? Which of these would help us identify identifiers? Now think how identifiers are unique. Which one? Why is this the correct answer? Because identifiers are based on unique things. They're special case categorical variables, hints for later. Identifiers are special case categorical variables that cannot, will not, ever repeat. What is the only type of variable that I haven't talked about that would be defined as... What is the only variable I haven't talked about that would be this one right here? If we say like what group? Categorical, exactly, Morgan. Categorical is going to put things into categories. So we have here what group. If you notice, we're just reviewing chapter 1 a little bit right now, kind of an easier chapter when we have like quantitative, categorical, identifier. We have, can anyone ask me a question that would lead to a continuous quantitative answer? Ooh, let's do a little review right here. William, I want to know what you like. I want to know what you like. You got to tell me one thing that is not trash. You got to tell me one thing, because I think William has two groups. William has a categorical variable, things that are trash and things that are not trash. And I want to know what falls into the not trash. There we go, ice cream. Ice cream's good too. What is wrong with custard? There we go. So, oh man, I love custard. So good. Eggplant parm. Eggplant parm we know is good. Eggplant parm, right? So we're asking some categorical questions right here. We are having William categorize these things right now. So this is leading to categorization. So categorical variables just put things into groups. It's the only one we really haven't talked about is goat. So wait, now we have like, but that's like a subset now you see. So now we got like things that are not, what have we done? Cute Dolphin, how are you doing, Cute Dolphin? Oh, hanging in tight there on 5th place. We got Created Works. I don't even know what that is. Awesome Cheetah. I mean, who are you rooting for right now? I mean, you're probably rooting for yourself. On this leaderboard, I want you to root for someone and say, you got this so-and-so as we start here for the next question. I'm not going to go yet, but who are you rooting for? I'm rooting for a Cute Dolphin. That might be you. But hey, good to see you here, Roderick. We're doing mini-term right now. Roderick, if you want to help out, if you want to put some answers in the chat, and the code is behind me, so you can join in if you want. Do a little review of Stats. And good to see you, Roderick. 320 student. Dan, join in if you want to. Join in, Dan. Join in, Roderick. Awesome, Cheetah. You got this, or root people on. Go Royal Giraffe. I'm rooting for Cute Dolphin on this next question. Which of the following graphs can be used to make univariate categorical? Univariate categorical. Univariate categorical. Like we were just asking William questions about what he likes, what he doesn't like. We could display this information in a what? We could display this information like, think about this. We have to count it. No, that means it's not quantitative. We're actually counting like, there were 8 items described as like goat, and then 10 items described as trash. So how could we display this? We could display it in either a bar chart or a pie chart. Who can remember my favorite phrase? You can do a what of a what, or you can do a what of a what. You can just say one of them to start, but it helps you remember that these two are linked. Like you can ask someone the blank of their favorite blanks and make a blank of it, or you can ask someone a blank of their favorite blank and make a blank of it. I had a hen cook it counter. I thought you were serious for a second, Haley. 20 points, Haley, right there. I think we should make that a quote. We're trying to get more quotes right here. I like that. That's one of those jokes that people are going to be like, Brian, did you write that joke? And I'll be like, I totally didn't. People are putting my quote in there, which is actually, it's a quote from How I Met Your Mother. You can make a pie chart of your favorite bars, or you can make a bar chart of your favorite pies. So remember when you ask people, what's your favorite bar? They would say something that's categorical. When you ask someone, what's your favorite pie? They'd also say something exactly. Roderick knows right there. You can make a bar chart of your favorite pies, a pie chart of your favorite bars, and those are both categorical responses. Yes, it is totally a quote. That right there is a quote right there. That is quote number 77. Quote number 77. That, Haley, is your quote right there. So feel free anytime you want the joke to be there. And that joke will be, I don't plan to ever remove quotes. I'm just going to keep doing quotes. So one day if you see me streaming, like Roderick saw me streaming right here, she'll remember some of the quotes from her class. And How I Met Your Mother is a great show. Yeah, there's two. Sometimes there are two answers, like maybe with the next question coming up right here. Let's do this. Wait. Cute Dragon, you can go away. Do you guys see this? Cute Dolphin's gone. And you know what happens when Cute Dolphin's gone? I'm gone. Game over. Class over. Let's go. I'm kidding. We're all back. Yeah, we just kids. Let's do this. Let's see who's going to win here. Next question. Which of the following graphs can be used for bivariate categorical? Maybe there's going to be 2 right answers on this one. Which of the following can be used for bivariate categorical? It's always been cute. Oh, has it been? William, if it has been. Really? I'm so blind. Oh, man. I'm going to play my own music now. We're going to listen to my own music. Bivariate categorical data. Bivariate categorical data. You've got your 2 friends right here. Oh, no. Okay, we got to help people out. This is bivariate. But what's going on with this right here? What's going on with this right here? Cute Dragon, I'm sorry. Come back. What's going on with these right here? Remember we did scatter plots today? I think that's why it's fresh on everyone's mind. But what's the deal with this? William, you are correct. So does everyone see what William's pointing out? I know right from one letter what William's trying to imply right here. So what is William telling us about time plots and scatter plots? Because remember, a time plot is a special case scatter plot. Scatter plots are two quantitative variables. QQ, straight enough, no outliers. QQ, straight enough, no outliers. So remember, mosaic plots and contingency tables, this is where we're looking at things like, do you own a pet and do you live on campus? So QQ, straight enough, no outliers is for scatter plots and time plots. So have this written down, and let's look at our graphic again real quick. I want to encourage everybody. I wrote these down on the board. Oh, I've got a quicker way of getting to it now. I made it. So everyone's checking out all the quotes now. Sorry. All of these are memories for me. Like these are all things that students said or I said or things like that all become quotes for the class. So have a picture of this if you want. We're talking about the bivariate categorical, which I'm over right here. This is bivariate categorical, and over there, which I'm pointing inside of it right now, is bivariate quantitative time plots and scatter plots. We won't do logistic regression in this class. Pepperoni Pizza Club, that's when students were like, we should start a Pepperoni Pizza Club, and I had Mubot spamming that, and they're like, please have them keep spamming that. Literally I'm not joking, the whole stream for a moment when that day happened was the class like doing this, like the whole class was streaming, like it was like 100 students. I don't know. It was really active, and everyone was just like spamming that in the chat. And I was like, sure, Pepperoni Pizza Club. You never know what's going to happen. Cute Dragon. I'm back on Team Cute Dragon. Hashtag Team Cute Dragon. You got this. Hey, Jensen, good to see you here. Team Cute Dragon. Jensen knows some quotes there too. Going on, here we'll focus. Everyone ready to focus? Take some notes. Here we go. Time to focus. Serious face. Find the IQR of the distribution. Find the IQR of the distribution. Good to see you, Jensen. Thank you for swinging by. And you're free to play along if you want. And offer tips to students. What is the IQR? The IQR is the range of the middle 50%. So you'd say, Brian, you didn't give me the proper information here. But wait a minute. Take a look. You can see the IQR right here. The IQR is the box of the box plot. Now the min and Q1 are here. The median Q3. The IQR is 2. So remember the IQR. This is the note you should have for this graphic. The IQR. Oh, the bin width. Oh, did you get hit by bin width? The bin width is 1. It's actually, so remember, the bin width is 1 right here. So sometimes there's a bin width question on the test. But what do you notice about this distribution, which might help you out for a later question? This distribution is very, very what skewed. This distribution is very, very what skewed. I can never round. What is this right here? It's right skewed, right to the high, left to the low, whatever way the tail goes. And someone might be watching this right now being like, Brian, I got no clue what's going on. What are you talking about? Right to the high, left to low, whatever way the tail goes. Well, we got to draw our monster man. What up, monster man? There we go. Right to the high, left to low. Jensen, if you hang out, Jensen, until the end, you'll get to see our special guest as per usual. Have fun. Good job, Roderick. If you're taking a class in main term, great work. So please ask questions. I don't want to go too quickly tonight. We've already done a lot of questions, but does everyone understand right here how we found the IQR? Please ask questions if you don't. What is the maximum in this data set? So I'm just going to ask a few questions on this graphic. Make sure you can read it. What is the maximum on this data set? What is the maximum on this data set? Can you put an arrow at the end of the tail? Easier to understand in the beginning. An arrow at the end of the tail. 8, you are correct. William, what do you mean by an arrow at the end of the tail? So this is the maximum right here. This right here is actually the highest point that is not an outlier. And it's actually where the upper fence is, because the upper fence would be 1.5 IQRs above where. So make sure you have this note, sometimes on the test, that the upper fence, which is we go above this, and where's this start? This is where? Where am I at right here? Oh, can you put an arrow at the end of the tail? Oh, that's a really good idea. William, I'm throwing 50 points. I'm going to start doing that, William. Remind me from now on to put an end on the tail of my monsters to like point in that direction. That is Q3. That is correct. I see what you're talking about when I draw my monster man. You're saying put a little arrow on his tail like he's a dragon. So he's got that arrow tail right there. And so you can see which way it points, which way does his tail point. So he's got like one of those dragon tails, little devil tail right there. Exactly. I think that's a great idea. How do you find the skew looking at the box plot? Great question. When something is right skew, what do you notice? And we see it right here. So looking at the box plot, you can actually tell the skew. And so let's go ahead and copy it. And how can you tell the skew looking at a box plot? Well, first off, you have these. These are outliers over here. That's horrible. Highlighter is not meant to be written with. You also see this elongated tail right here, more stretched out. Also, this. This is not included in all box plots, but that's the mean. And what do you notice about the mean versus the median? What do you notice about the mean versus the median? What's going on with that mean versus median right there? The mean is what to the median in this? So Jump will put in the mean for you, which is a really good indication. You can tell it's right skew by the elongated parts of it. So there's a few good indications here. You've got the right tail pulled out, but the mean is what to the median, which indicates the skew. It's higher than. Does that make sense? The mean follows the skew. That's a great note to take, that the mean follows the skew. When it's skewed to the right, it'll pull the mean in that direction. Also, just the longer tail right here, let me highlight that part. This right here being pulled out in this direction, all of this right here, because what percent of the data, I'm going to put 2 regions on this. Last question on this one. Here's one region, and here's another region of the data. So in region A, what percent of the data is there? In region A, what percent of the data is there? What percent of the data? This is a good question too. This would be a tougher one. Great job, Tyler, right there. Mean is greater than the median, indicating right skew. And then in region A, what percent? Exactly, William. Because it's right where the 75th percentile is. That's Q3. And so above here, all of this is 25% of the data. And does everyone see that the top 25% is pulled out more, indicating a right skew, that it's pulled out to the right side? So it is skewed to the right, to the high, and great work. Who's in the lead now? Cute dragon. He'll come back here. Make it happen, cute dragon. Next question. The group of individuals or things that we want to understand is the what? The group of individuals or things we want to understand is the what? I'm going to mention all these key terms after we do this right here. The group that we want to understand, that we are like saying that is the blank of interest. The thing, the group we want to understand. All people are things we want to know. And so close answers right here it was a mix of population and sample. So the population is everything we want to understand, and then the sample is everything we collect what on. 4-letter word. Everything we collect what on. The individuals we collect this on will be our sample, which is our insight into the population. So we collect data. I'm saying it now. We collect data on the sample, and from samples. And so I want you to write this in the chat. SSPP. Now, the reason we're typing this is because sample statistics, population parameters. So if I were to tell you, great job right there, Krista. What would it be if I told you I talked to 100 students and on average they go to the TREC 12 times a semester? Would that be a sample statistic? And just type SS or PP. Would that be a sample statistic or population parameter if I said I talked to 100 students and they go on average to the TRECs 12 times a semester? That would be a sample statistic. So the students, the 100 of them, is the sample, and then the value of on average they go 12 times is the statistic. But let's say UT has information from card swipes from students. Like UT could know about the what? UT could know about the population because they have the card swipe at the TREC. So they could know for all students that on average, all students go on average, let's say 13 times, like somewhere around that. Let's say like my sample was actually representative. So maybe UT knows this, and now people are saying population parameter, because how many students would you have to have information on for it to be a population parameter? If you're collecting data on students, for it to be a population parameter, how many students would you need to have data on? All of them, exactly. So when we're doing a census, is a census... Oh, here we go. There it is right there behind me, Haley. When we are doing a census, are we collecting the whole population or are we collecting a sample? When we do a census, are we collecting a population or are we taking a sample? When we do a census, when we are doing a census, are we doing collecting on the population? We're doing a population, everyone. Exactly. Census means to, like the 2020 census, it means to get data on everything. And what does parameter mean right here? I think it's confusing. Like parameter is just a confusing word. It just means like if they want to know like the income of US citizens or something like that or whatever, then they want to know for everyone. Parameter is just the idea of like a statistic for all things. Does that make sense? What a parameter is? Like, let's say you want to know the parameter of the mean age in your family. Then you would talk to everyone in your family and average together their age. And then you would know the mean age of everyone in your family because you have data on everyone in your family. And then the mean age is the parameter. Does that make sense what a parameter is? But if you only talk to 2 people in your family, you have a sample. That's a rather small sample. And then the mean you get from that would be a what? Last question on this. The mean you get by talking to 2 people in your family and taking the mean of that would be a what from your sample. So the mean you get from 2 people in your family, you just talk to 2 people and you say, what age are you? You average that together. That sample would give you a what mean. It would give you a what. That mean would be a what. The mean you get from talking to 2 people, not everyone, would be a statistic. Does that make sense? So samples give you statistics which try to estimate population parameters. Does this make some sense right here? We're going to be covering this more for test 2, so I'm laying a little bit of groundwork, but these terms like population are on the test because the goal of statistics is to make inferences into populations. Let's see who's in the lead right here. We got some big questions coming up. Cute Dragon's back. Like that right there. Perfect job, Cute Dragon. Let's listen to the Mario music. Let's do this. Let's do the Mario, and let's do the next question. Here we go. Which variable is a special case categorical variable? You got this. Back to easy questions again. Who knows? Which variable? Which variable is a special case categorical variable? Questions are about to get more difficult in a moment here. Identifiers. Identifiers are unique categorical variables. Continuous variables are quantitative variables that can have decimals. Nominal variables are categorical variables that don't have any sort of order to them. Like if you said something like, what's your favorite ice cream flavor? That's nominal. But if you said something like, what's your steak preference from rare to well done? That's ordinal, like it has order to it. Discrete variables are quantitative variables that are whole numbers. Any questions on this? Any questions on what is a continuous variable? What is a nominal variable? What is a discrete variable? This right here is a quantitative variable, but it's continuous. It's like a subtype. Discrete is quantitative, but whole numbers. And then nominal and ordinal are different types of categorical variables. Identifiers are special case categorical variables that have one level. Great job, Megan. Thank you so much, Megan, right there. I'm throwing some 20 points as we look at the leaderboard. I appreciate people even just saying, I'm good. Lets me know. Cute Dragon. Maybe I should keep calling you Cute Dolphin, and then you'll win. That moment when your Kahoot tells you you're 800. Oh no! Hey Tyler, yeah, I agree, Tyler. I'm all about that medium rare. William, what do you think of medium rare steaks? We gotta ask William what he thinks of it. William, as we start this next question, we'll let William tell us after he answers it maybe what he thinks of medium rare steaks. Here we go. Time plots are what? Time plots are special case whats. So we actually have 2 time plots here, kind of graphed on top of each other. But each time plot is a special case what? Hint, QQ straighten up, no outliers, rare only. Williams like, how about Pittsburgh? Would you accept Pittsburgh as an answer for how to cook your steak? Pittsburgh style. Try Pittsburgh if you haven't. So as long as you like rare and medium rare. So time plots are special case scatter plots. Time plots are special case scatter plots. Make sure to have this written down. Pretty good job on this one right here. Dot plots are what? Dot plots are what? Who can explain the chat? Explain to everyone what dot plots are, because that was the next highest answer. A dot plot is a what? I agree, Tyler. Actually, that's a really good answer, Tyler. Nice restaurant, get Pittsburgh style. Got all the steak discussion going on. What are dot plots? We need to know, because 5 people right now might be wondering, wait, I thought dot plots. A dot plot, moo. A dot plot is a kind of another way of doing a histogram. So when it comes to dot plots right here, dot plots, which actually, do I have them on here? Where? Oh, they are on there. Dot plots are basically just another way to do a histogram, but the dots build up the histogram. So you can see them up there with histograms, but scatter plots and time plots are next to each other. Let's see who's in the lead right here as everyone debates steak preference in the chat. What happened to Cute Dragon? I'm sorry, Cute Dragon. I am sorry. Jensen, it's time. It's time for our special guest host. Who knows who the special guest host is? A lot of people don't know who the special guest host is. Special guest host, take over for a moment here. They need to come in. Are you coming in? You going to be here?
Yeah, I'm good. Oh, here I got it. Okay, I'm coming. What's up, everybody? I'm Tiny Brian. I'm the head honcho, not Brian. But here we go. Time for Tiny Brian. Okay. Which distribution has the biggest range? I'm Tiny Brian. Uh-oh, this question a lot of people get wrong. I see a little outlier right there. A little guy like me. Don't forget him. Don't forget this little guy. If you forget him, you're gonna get the question wrong. Tiny Brian. Tiny Brian. That's what they call me. What? Want me to go away, Brian? Yeah, okay, bye.
Okay, Tiny Brian, you're gone. Great job, everybody, right there. Tiny Brian was there to point out that tiny outlier. So, this one, I know, right? Maybe I should change up the questions more. It helps for me to know which ones people get wrong. I did make some changes this one, Jensen, so stay tuned. You're going to see some changes here in a moment. Some fun graphics are coming up. But the biggest range, I know you didn't see that little guy right there. Remember, when we do the range, always to include outliers. So this one right here is definitely the biggest range. Don't think, watch out, these points right here. You will see that they are not the ends of it. This is the minimum. This is the maximum. You notice also that we do have small outliers right here. All this good stuff right here. Which of these box plots looks to have the biggest, let's say IQR? I might have to go away. It's actually very hard to tell. What do you think? You can just put the start of it. Which of these has the biggest IQR? Yeah, Jensen, drop some tips for everybody. Jensen, drop some tips. The Fort might? Where's the Fort on here? Oh, there's the Fort Sanders. There it is. Yeah, that looks to be, it's either the Fort or 10 to 30 minute drive. It's hard to tell. That would not be a good test question. But the IQR is this of it right here. It looks like this has the highest median. And Jensen's going to probably give some tips here. I'll try to read them between the questions. But Jensen, drop some tips for everybody. Ooh, it's a close game. Let's see right here. Who's going to be in the lead with the next question? Here comes the next question. Get ready. What is the best measure of center for this distribution? You got this. I know you got this. What's the best measure of center? There's only 2 measures of center. Only 2 measures. I'll highlight them. So if you're watching the screen right now, the only 2 measures of center we talk about are this and this. Those are the only 2 measures. Remember, shape, center, spread. When we have shape, center, spread, you look at the shape first. This looks very right skewed to me. Very right skewed. Since it's very right skewed, the proper measure of center is going to be the median. Oh, I'll take that. I'll take that. You know what? We started with 17 people. We're still playing with 17 people. Thank you so much. Let's drop some 50 points in here. Come to the Kahoots. It's usually tons of points. Tons of fun. We'll give some points out to the winners too. Top 5 are going to get points 500, 400, 300, 200, 100. Why not? Some people are going to just get some crazy points tonight. So top points, message me. We'll see who you are. Just you can message me in the chat. And top points on the leaderboard, 500, 400, 300, 200, 100 for places in the reverse order. So I would definitely say keep it here. We'll go to the leaderboard while we talk right here. Oh, it's crazy. Expert Koala. I would definitely keep up with the homework, use the speed runs if you're lost and whatever you still understand, bring to Brian's office hours, and we'll definitely help you understand. Great advice, Jensen. Thank you so much. My biggest advice to them from the start has been do all the homework, do all the quizzes, and start early on the material and ask questions. So, Jensen, thank you so much. Everyone, just if you want to tag Jensen, say thank you. What's up, Lorca? Good to see you here, X. Oh my gosh, so good to see everybody. Just so many, just love seeing everybody swing by. Everyone ready for the next question? Here we go. Let's do this. True or false? Get ready. Uh-oh. Only outliers can make a strong correlation weak. Outliers can make the slope of a negative line positive. I mean, outliers can do anything, right? Outliers can do anything. I mean, keep hearing a beep noise. I don't think that's the answer coming. Outliers can do anything, right? No, I promise. This one's... So, outliers can do anything. But wait for it. just maybe be a little bit slower. There's going to be a hint for the next question. But what we're talking about right here, I'm gonna show it in R really quick. What we're talking about with outliers, core demo. I didn't show this today in class. So I'm gonna show it real quick right here. Tell me right here, this correlation. Notice that this correlation is very, very what? Does anyone see the value of correlation up here? The value of correlation is very, very what? The value of correlation, which is R. R is the value of correlation, is very, very what? I'm trying to make it there close. Weak. Very weak. How about now? How about the correlation now with this outlier? Now it's extremely strong. We go up here and we put that outlier, and now it's at 0.8. How about if we have a correlation now that looks something like this right here? This correlation is perfect positive, but if I go over here, oh, darn, it's like a game. So close. This correlation is now, that was horrible. Oh, there we go. This correlation was really strong. Remember just a moment ago when it was super strong, and now it's 0. Remember? Really strong, super strong correlation, close to 0. Is there, if we can, I think I'll see if Alyssa is available because we might start needing her help next week because she was a great resource. Can an outlier make this negative? Definitely. Does everyone see this right here? What can outliers do? I want to see you type it in the chat. I think I might be able to, I'll talk to her. We actually got an email from SI today, Jensen. Really great question. So we actually just got the email today. And I'm going to see, and by next week, we might have some SI help. So I'm going to look into that because I want there to be as much help. Outliers can do anything. You got a nice positive correlation here. Oh, wouldn't it be too bad if someone just dropped an outlier over here and oh, it's all negative now. Oh, no. Outliers can do anything. So outliers, when it comes to correlation, can make it positive, negative, weak, strong, you name it. Outliers can do anything. Let's see who's in the leaderboard right here. I mean, outliers can do anything, right? Be careful on this next question. True or false? Outliers can dramatically impact the IQR. Hint, outlier kryptonite. Outliers can dramatically impact the IQR or the median. Outliers, there's a hint in the picture and there's a hint on the screen. Ooh, Reese thinks it's false right there. I'd go with Reese. Small outliers can do anything. Asterisk. It's false. False. Code's right behind me right here. Outliers can do anything is a false statement. Outliers can do anything is a false statement. I know I just said it 1,000 times, but what if I were to have the numbers, let's say 1, 2, 3, what is the median? 1, 2, 3, what is the median? 1, 2, 3, what is the median? Doesn't aim. What is the median of 1, 2, 3? 2. What is the median of 1, 2, 10? Happy Lemming, keep it up. 1, 2, 10. 2. What about 1, 2, and a million? Everyone's still saying 2. Because outliers don't affect the median or the IQR because both of these are based on percentiles. I literally just had this like total, oh my gosh, moment when I was like, wait a minute. The median is the 50th percentile. The IQR is the 25th and 75th. That's why they're paired together, because they're both percentile based. And when you have outliers, like an extreme value on the far end, it won't impact something in the middle because it just doesn't matter. Like 1, 2, a billion, like 1, 2, and then a number, a billion. It doesn't matter. I'm saying like 1, comma 2, comma a billion. Outliers can do things by. Exactly. Great job, Haley, right there. I totally agree. Oh my gosh. Space urchin? Space urchin, I think you're cool. I like Snowy Llama too. Space urchin, Snowy Llama, you got this. I don't even know who these people are, but you got this. Let's see who's going to win the next question. Here we go. What is Q3 in this data? You got this. Be able to read box plots. This is a little chapter 3, chapter 4 right here. It's actually chapter 4. Be able to read box plots and know where Q3 is. A lot of people mistakenly think. Oh, good job, guy. Keep it up. Where is Q3? Is Q3 at 0? Is Q3 at 1? Is Q3 at 2? Is Q3 at 5? Q3 is at 2. Now, 5 is a common answer. This is just basically the highest point that's not an outlier. So the whiskers go up to the highest point that's not an outlier. That's a good note to take. I don't think a ton of test questions ask that. But you need to identify things like, where is the min here? Where is Q1? If you notice right here, this is number of pets that people own. I literally hear a dog barking right now. Not ours. We don't have a dog. We have a bunny. He doesn't bark. So with this right here, maybe we'll end with Morty. So what do you notice about this? A lot of people, like 25% of people, own what? Connor, what's up, Connor? I need to talk to you on Discord again, Connor. I hope your summer's going well. I hope everything's going well. Are we gonna do some TBS stuff? I wish I could. We don't pick up Morty much. Same as Morty. I don't know why. What do you notice right here? Brian would be here at the 50th percentile. I will end the stream with the bunny again. Can confirm bunny doesn't bark. I need to talk to you more about time series stuff. I'm getting that all ready for summer session 2. My brain's just like, which one? I'll put that in. Here we go. We got another quote right here. It is in, I think it's quote 78. With this right here, I think we know what's going on with the box plot. Let's find out. Chelsea will like that. Charming Bobcat. Ooh, charming Bobcat. Let's find out who's going to win with the next question. We're about to, and so I want to say this. We're about to go to new material here very soon. We're about to go to some material that we haven't covered that we're covering tomorrow. So get ready right here. Let's do this. What is the equation for a residual? Now, the equation for a residual is the residual equals the actual minus the predicted. You can see the graphic on the screen that shows it. So find the right answer. As I say, residual equals actual minus predicted. Residual equals actual minus predicted. You'll see it on the screen. So this is the first time you're hearing this, and you'll hear it a lot tomorrow. Residual equals actual minus predicted. So which one of those is it? Click the button real quick that shows residual equals actual minus predicted. And hopefully you're studying these topics and learning them here. So this is the formula right here. Residual equals actual minus predicted, also known as E equals Y minus Y hat. And let's take a look at the picture. In this picture, you can see the residual in gold right here. Now the predicted is on the what? Who knows where the predicted is at? Predicted. The predicted are things that are on the what? The predicted are things that are on the where. All the predicted values come from the what of best fit. All of the predicted values are given from this want. Basically a trend line, kind of like a trend line, just a line. Great answer right there, Megan. All the predictions come from the line of best fit. Exactly. And then we have here a blue dot. I tried to color it the same color as the dots. And you'll notice that this residual is negative. Now, what do you think the value of the residual is for this point right here that's right on the line? This point that's right on the line probably has a residual of what? Remember, a residual is just how much we miss by. So if a point is right on the line, it would have a residual of 0. Great job, Megan. Now, what about this point? They would tell me, Brian, this point has the whattest residual. Like, look at it right here. It's very, like, if you drew its residual, it's just its distance down. So this one has the what? What is residual? This point right here, it's residual, which is just how much we miss by. So it's like, this is the prediction right here for it. It has the largest. All a residual is, which is notation E, that's the notation for it, is how far away a point is from our prediction. So this point right here was 22. Its prediction was 36.6. And this right here means it's 14.6 below its prediction. So you can see here, I call it residual equals actual minus predicted. And the formula is residual, which is E, equals Y, which is the actual, minus the predicted, yacht. Oh, Y hat. I can't spell. Or round. Continuing on here, let's find out. Get ready for the next question. It's about to start right here. We got Blue Dove. I haven't rooted for you yet, Blue Dove. You got this, Blue Dove. I want to see you win. You're still on the leaderboard. You got this, Blue Dove. Make it happen. When percentage of track runners are expected, what percentage of track runners are expected to run 290 or higher? Oh no, please tell me I corrected. I had a mistake on these things a long time ago. Oh God. Brian's going to double check his answers in the background right here. Brian's having one of his classic Brian heart attacks. Classic Brian having a heart attack on stream. Oh no. Oh no, it's good. I'm checking the last two answers because, okay, good. Oh wow, amazing job. Just complete and utter. Great job. Can anyone... I'll call sometime. Exactly. Thank you so much, Connor, right there. I think that's what we were talking about. You were looking over some applications and stuff. Connor took 201, 320, 474. Connor, if you want to, we've had a bunch of students coming by and giving the mini-term students advice. But if you want to drop them some advice, and Connor, I just want to give a huge thank you to Connor. Connor used to come to my office, and he would help out students. Just, I would be working with students, and Connor would just be like, do you mind if I write on this board? And I'd be like, not at all. And he would just go through and start doing examples for students and explaining concepts to a lot of 201 students. And I miss those days. I miss just going into my office and drinking Red Bull, coconut Red Bull. Everyone knows coconut Red Bull. I need to buy some coconut Red Bull. That's William. What do you think of coconut Red Bull, William? We have to William weigh in on coconut Red Bull. If you haven't had it, you can't give your opinion. So, William, we're buddies now. William, wait, what? You can't do that to me, William. Music over. Can't do that to me, William. You're welcome, Jensen. You're welcome here anytime, and thank you for swinging by. So, Dr. Seaver had me drink a lot of... Does everyone notice right here, will the exam question be more like these Kahoots? They're more like the Canvas content, but these are good reviews right here. Let's take a look at this question right here. They're kind of a mix. I take some direct questions. It's just hard to do a full question on a Kahoot that would be right here. But what percent of area have I drawn between these arrows? Who knows what percent of area I've drawn on these arrows right here? Who knows what percent of area I've drawn on these arrows right here? What percent of area? We covered this today. What percent of area is on this arrow line? You have to use your numbers. $95. What we are looking for with this question is we are looking for the following. We are looking for this area right here. This is the area we're looking for. So how about we put right here, let's go red pen. We don't want this. How am I getting these 2.5s right here? How did Brian find 2.5? This is a review from today. How did I find exactly, Megan? Great job. So does everyone see what I've drawn here visually? I'm going to shade over it so you can see. Don't worry about that 68% now. But does this make sense right here? And the real AJ, great job AJ, is pointing out you can add up the 0.15. Great job AJ, remembering those numbers. You can use the 0.15 right here and the 2.35, which adds up to 2.5. So right there, remember 2.35 technically, because it can lead to small decimal differences. This is called the empirical rule. Empirical rule. So remember this right here, the 68, 95, 99.7 rule, which 99.7 is within here to here. Okay, great work on this question. Who's in the lead? We're going to do some Canvas content after this. Ooh, that's a shakeup of the leaderboard. Let's see who's in the lead after this. I don't know. Next question. Here we go. Which percent of area on the graphic is shaded according to the empirical rule? Another tricky one, but last question will help out with this. What percent is shaded on this graphic? If you know the answers to these things, you're pretty good for the test. Like, if you can look at that graph and be like, oh, according to the empirical rule, that's that blank percent of area. Try to think above 0 is what percent of area, and then above 2 is what percent, and chop that off right there. So above 0 is what, and then above 2 is what, and then remove that area off of it, and you get 47.5. Great job. We've done a lot of review today. I was doing questions like this in class, or at least showing the applets and stuff. But is this making more sense? Are people feeling a little more comfortable with doing the empirical rule with like the 68, 95, 99.7? Also, does anyone know another way to solve this? Like if you go from -2 to 2, what could you just do to get this right here? Like instead of going 50% above and then removing the 2.5, you could just go from -2 to 2, and that would give you 95, and do what to 95? Like, what's an alternative solve? Exactly, Megan, right there. So there's a lot of ways to check your answers and be like, wait a minute, that's half of -2 to 2, so I'm just going to cut 95 in half. So great work right there. Let's see who's in the lead. Knowing how to handle the empirical rule, knowing how to do questions like that. So once again, Canvas content, really great work. The Kahoot, you have to ask like quicker questions. But these are very much like, you're ready. Yeah. I will say this, a lot of the people who do well in the Kahoots do well on the test. It doesn't mean you will do well, but usually I hear from the students and they're like, oh, I aced the Kahoot and I got like a 98 on the test. I'm like, yes. So don't worry. And don't worry if you do bad on the Kahoot. There's lots of time to practice. Test is not till Saturday night. So be asking questions and be doing the work. We got this. We got this. The ones I really know how to do. Here we go. Let's do the next one. A stat to 1 test is normally distributed with a mean of 75 and a standard deviation of 5. What percent of students make above a 70? I'm getting scared. This question even scares me. Good. Good.
Good. You have to draw this one out. I didn't draw it out for you. Think. Turn it into a z-score. I have an evil voice right now. So the mean is 75. The standard deviation is 5. Who knows what the z-score is for this? Any ideas on that z-score? What is the z-score? And anyone know the area above it? Uh-oh. This is a tougher one. The area above. What's the z-score?
Who knows? -1. Great job, Sarah. -1 is the z-score. Connor knows. Good work. That was a tough one. With these types of questions, with your scratch paper, what you doing, Microsoft Word? Microsoft Word going crazy right there. So that was a tougher question right there. Definitely one worth kind of drawing out, making sure we see how to do it. We draw out our normal curve. And when we write the notation, we write normally distributed with a mean of 75 and a standard deviation of 5. And we go right here and we put 75 at the center. And then we go down and we go up. And we put here 70, which was the observation, and 65. Now, I just want to make this very clear that I am going down 3 standard deviations and I am going up 3 standard deviations. So this is going to be the context one. And then usually what I draw below it is the z-scores to help me see, because I'm blind. Like, kind of, sort of. Now, we were interested in above a 70. Above a 70 is going to be right here. And so how about we talk about the area between here and here, which is what? I need people's help. I forgot. I do not know. What is the area between a z-score of -1 and 1? What is the area between a z-score of -1 and 1? What is the area between a z-score of -1 and 1? Who knows the area between a z-score of -1 and 1? 68, 90, not 95. 68. God, it's cracking me up. 68%. And 68 right there is the area between that. So now we want to do the outside. The outside is going to be How much is total outside? 68 inside. Now subtract from 100. What is total outside? Oh, that's really good right there, Tyler. I'm going to throw 50 points for Tyler. Just speed running that question right there. I'll show you Tyler's solve here in a second. That's a really good 50 points, Tyler, for speed running that question. There's lots of ways to solve it. And Tyler said, you know what? Instead of doing it this way, Tyler did an alternative solve. Got some strats we don't even know about. And Tyler went here and said, okay, I'm going to go right here. And I know that that is 68. So he goes here, cuts this. This is 50. And then he cuts this right here. Well, since this is 68 right here, he then cuts this into 34. So we'll put that up here. But that's got it. And there you go. Great job. That's totally another way to solve it. But 50% above the mean, and then 34% between 70 and 75. Great job, Tyler. Great answer right there. Lots of ways to solve these. And so I like when people are like, well, you could also solve it this way. And just you can confirm your answer then. But make sure to, we talked about this today in class. If you know these numbers, it really helps. These are the additional numbers. I think AJ's got them down really well. They were mentioning, I think it was AJ, right? Just like saying like ace in these questions. So if you like memorization like I do, there's the numbers right there. The 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. I'm totally going to tell Chelsea about this quote now. But let's see. Beyond quotes, who's in the lead? Who's in the lead? Champion Eagle soaring into the lead here. It's going to happen. Champion Eagle. I don't care that Joyful Octopus is just doing an amazing job. Great job, Joyful Octopus. Who is in the lead? Let's find out. 68, 95. I don't know that last number. What is that last number? I'm going to feel so sad if anyone gets this wrong. Puppet Shark, do you know the answer to this? You know every answer, Puppet Shark. You know it all, man. That's one of my favorite quotes right there. Quote 44. I can't remember who said that. We just were dying in class when someone said that. 60. Oh, no. No, why? Maybe someone just did that to be mean to me. Don't do that to me. I need to see a few people. Send me your energy right here. Send me your energy. Come on, everybody. I need the energy right here. Like, not some DBZ style. I need some 68, 95, 99.7 in the chat. I need some 68, 95, 99.7 in the chat. Connor Moore is doing 5.5758, aren't you? Are you doing 99% comments rolls 2.5758? Wait, what is plus 2.58? What's going on? 68, Anthony right there. That is just building me up right there. I'm going to hit just a random song here. I don't even know what this is going to play. Oh, it's not going to play anything. Little punch out music right there, building me up. 68, 95, 99.7. Silly Puppet Shark. Let's make this happen here. Sounds like video games. Here we go with the last question. 68, 95, 99.7. Get ready for the last question. Might be a regression, I think. I can't remember. Last question is true or false. Predicting index of 30 for either company would be an extrapolation of this model. Ooh, one of our favorite topics, right, Connor? Connor knows what topic this is. If you are predicting outside the bounds. Oh, yeah. If you're doing outside the bounds of a model, it's coming down to a true or false. Extrapolation is when you go outside the bounds on the what variable. Extrapolation is when you go outside the bounds on the what variable. Like when you make predictions outside the bounds of the what variable. Wait. Is that Futurama? No. Just Joshua, good to see you here, Joshua. Extrapolation is when you go outside the bounds of the... Is that it? I always get independent, dependent confused. It'd be the X variable. Extrapolation. And Connor knows I like to accentuate the extrapolation of it. So when you go outside the bounds of the X variable, if you notice right here, if we make predictions out here, Connor, do we sometimes make extrapolations of models to predict the future in time series? Like, do we sometimes try to predict into the future? He's not allowed to have M&Ms. Do we sometimes make models that predict into the future what might happen, like extrapolate and forecast into the future? All the time. You have to watch out with extrapolation, though, because it leads to uncertainty. Extrapolation, unless you're doing it carefully, can be very iffy. So we don't always want to extrapolate our models. We want to be very careful that the data we're putting onto is properly calculating it. How far can you go, though? How far can you go? Let's do this. Champion Eagle, I want to see it happen. Oh, I should have put like double points. You know what, Tiny Brian? You wanna go? You wanna talk to them? Yeah.
Sorry, my voice, it just changed. Here we go, everyone. I have to do the announcements. Here we go. Oh my god. Third place. Where's Champion Eagle? Great job, Champion Eagle. Yeah, that's one. Snowy Llama, and you know Octopus. Octopus doing a great job right here. Yeah! Joyful Octopus, great job. Tiny Brian.
Tiny Brian, you're so crazy. Now, if you are in 1st through 5th, please tell me, I'm going to bring up the screen right here real quick. We're going to do a little Canvas content too, because there's some Canvas content questions. But if you're in 1st through 5th place, do this right now. Just put 5th place, me or something like that. Put that in the chat, and then I'm going to add the points to you. 1st place is worth 500. And you know what? We're going to give 100 points to everyone who's still watching right now. So if you're here watching live, you get 100 points. But 2nd place right there, Guy. Great job. And I'm taking everyone's word for it. We'll put a little music on in the background. Let's go. We don't, there's songs we don't listen to. Little wake up music. Got a little work here. William, great job. That's not trash there, William. That's excellent work. I'll throw some 50 points for Cute Dragon right there. Cute Dolphin, Cute Dragon. I'll throw some 50 points right there for that. Got a little working music right here. Okay, so William. Adding on, this is the adding points music right here. We got Guy. Guy was in 2nd place. That's 400 points. We got Caitlin, 5th place. That's 100 points. 5th place, 100 points. Great job, everybody. We're just going to add some more points. Anthony right there. 50 points, Anthony. Great job, 6th place. Go. I was 11th, Morgan. I'll give you 20 points for 11th right there. I'm like typing. We got enough time. Music's still going. I am so blind. Morgan, I want you to check out your points. If Mubot updates that status, you just reached a new milestone, Morgan. That 20 points just pushed you over to the 2 points right there. Did I not say anyone's name? That 3rd place, Tyler. I don't think I added Tyler's and Brooks. So let me add. If there's questions, I'll answer them in a moment here. I'm just making sure I got everyone. Brooke got 4th place. That's 200 points right there. Great job, Brooke. And Tyler. I don't think we did Tyler's yet, did we? If I did, then we're double points here. Did I? Well, there we go. I think it's got everyone. Oh, it's YouTube copyright free music is what it is. I hope it is. Megan, let's throw Megan some points right here. And thank you, everybody. There was really good competition tonight. Here, we'll put on another song. That's too cheesy. This is our Elon Musk music. We were talking about Elon Musk before he was on SNL, before he was cool. We were all about some Elon Musk going to Tesla. I got 16 plays from where my phone crashed on 12 questions. Let's throw some points out right there. Haley, thank you for hanging out and asking questions. And just like playing, like some people, get behind and they're like, well, I'm not going to win. That's what William thinks about Elon Musk. See, we got our compass in the class. We got William to tell us what he thinks. I like that. I am totally fine with people sharing their opinion. I was space searching. What place did you get? We're just throwing out points right now. I think AJ had a question. I don't know what place I was. Elon Musk is your favorite quarterback? He's my favorite quarterback too, but he doesn't play that much. I don't know. I think he's taking some time off from the NBA to not play any football. You know, who's pitching for them? No more football for Elon Musk. I say top 5 within reach. Are we doing canvas content? Yeah, we do a little canvas content. Let's do a little canvas content. Ready? What? I think AJ, did you have a question on canvas content? Oh, Tom Brady greater than Elon? Well, they got to go head to head. They've never played head to head, so I don't know if I can make it. Elon, the reason my Doge is down $200. No, some Dogecoin literally going to the moon. Which questions do people want? What do people want to do? I'll hang out for a little bit here and we'll... If you are here and you have a question, let me know. I don't have exit full screen. All right. I'm playing my favorite like crazy song. I think I want to hear. Yeah. And the chapter 5 quiz part 2. Nope, question number 2. Yeah, which one did you want, AJ? Not this one. Some like anime music. What's your question, Connor? I'm gonna put on chill music. We can't go that crazy. Chill music. So AJ, feel free to let me know which. Do you want to just do one version of the canvas content? I think there's a canvas content due tonight. What's the vote right now? Chapter 5 or one version of the canvas content? What's the vote? I'm getting everything loaded up right now. What is the vote? Morgan might also be. Which one do you want to vote for, Morgan? Based on them all describing steer weights and the cutoff. Okay, let's do the cutoff for steer weights, and then we can do a canvas content. 2 seconds right here. Cutoff for steer weights. Steer weights cutoff. Mubot. Does anyone want to call the David M. Lane applet in the chat right now? You can also do this. I don't think people know this, but who wants to call the David M. Lane applet for us? So while I'm getting the steer weights question, I want you to call the David M. Lane applet because you can do this at any time. Mubot knows a bunch of commands. Mubot knows things like if the class is not in HD. Mubot knows all different things. Mubot will tell us about putting the class in HD. Yeah, we're going to do it here in a second. You got it. Let's see. I got the steer weights question. Ready to go. Mubot. Mubot, wake up. Here we go. I typed David. It's David. Sam, what are Sam and William talking about? I have no idea. I have no clue. Mubot, tell us about that David M. Lane applet. Go here for the David M. Lane applet. Cool. Okay, let's make this happen. Okay. So the David M. Lane applet, let's hop over here and do these questions. Let's do it. Okay. So with this question right here, we're talking about steer waves. I have no clue. You guys are going to have to inform me. I am not a man of culture. So with this right here, we have that the cutoff for the highest steer weights is the highest 10% is going to be a certain weight. Now remember, the David M. Lane just dropped in the chat, so that way we know where to go. Now, the highest 10%, we would know visually speaking, is going to be somewhere about right here. Now, why is the highest 10% here? Because, think about this. The highest 16% would be where? The highest 16% is at 1 standard deviation. Oh, Naruto? I know some Naruto. So, I've seen more than that. The highest 16% is right here. The highest 2.5% is right here, which means the highest 10% is going to be somewhere in here. So the highest 10% is right here because it's somewhere above the highest 16%, somewhere below the highest 2.5%. So now all we have to do is put in the values. So let's go ahead and grab those values right here. We see a value of 1159 and 89. So 1159 and 89, and there we go. Here is the cutoff for the highest weights for the top 10% of steer weights. So we just go here and round to 1 decimal, and we got it. Now we want the lowest 20%, not the lowest 10%. To do the lowest 20%, that is correct, right? We're just going to switch this around here and do the lowest 20% right here. So the lowest 20% is now graphed, and this is the 20th percentile. If you show this, This is the what percentile right now. Who can tell me what percentile this is? This is not the answer right now, but just look at it and be like, hey, Brian, that's the blank percentile for steer weights. Look at this information right here and look at this. Brian, that's the what percentile for steer weights. What percentile is that on steer weights? Is the top 20? Well, so it's the top 20%, but it's not the 20th percentile. The 20th percentile would be on the low side. It is the top 20, making it the 80th percentile. Does that make sense to everybody? Like when we talk about percentiles, the higher percentiles are on the right side of the curve. Like if you score in the top 1% of the class, then your grade, and this is not grades, but it would be up there in the 99th percentile. So that's the 99th percentile, which is the top 1%. So if we want to get the lowest 20%, we want to do below. And then we just take the answer right here. We properly copy it. And then we go over here and we paste in the answer. And we want to do between right now. So let's go here to between. And it said the middle 40. So we go here and we put in the middle 40 and we get our answers. So we're just going to copy, paste the answers. Best way to make sure you get it right. Make sure it says the middle 40 and then copy, paste the answers. There we go. I think that's got it. No errors today. Not today, my Pearson. So there is the top 10%, the lowest 20%, and the middle 40%. We got time for a little bit more. What other One Piece is greater than Death Note? William, greater than Attack on Titan, greater than Naruto, greater than Black Clover. Is Black Clover, right? Is that JoJo? So what's it called? Bleach? Season 1 Bleach. Where's William? I asked that you re-rank these, and you're gonna have to put more questions if you got them. You're gonna have to throw those in there, William. I think I saw the Soul Society arc. Did I see that? I remember they went to like some big, I don't know. I watched like 2 or 3 seasons of Bleach. It's like a DBZ where it just takes a while. Full Metal is new 3? It's new 3. I have like the same questions, but it's asking about percentiles instead. Yeah, let's go take a look at that. I think it's the next one. How we do this on the test without the interactive. So on the test, and we did some example questions in class today, and also the Canvas content show it, you will get pictures of the applet. So here, I'll write a test question for you right now. Here's how a test question could look. So we'll do an example test question, and then we'll do, so let's say you get the following picture. Okay. And let's go here. This is a tougher test question. You ready? I'm going to give you a test question here, and then we've got a... Let's do an example test question. Okay. Test scores are normally distributed with a mean of 80 and a standard deviation of 10. What is the 90th percentile of test scores? So immediately when I get a graphic like this, I'm going to start drawing on it. I'm going to start like labeling it and making sure I have it. And then we'll do the finishing time. We'll do the other steer question here. So I'm going to start labeling this graphic. Do you see how this 80% right here? That's the 80% on the area. So we're going to label it right here as 80%. What percent are these arrows each worth? I'm asking it a little differently right now. What percent are each of these arrows worth right here? What percent of the graphic are each of these arrows worth? What percent of the graphics are each of these arrows worth? What percent of the graphics are each of these arrows worth? Like what percent of area is underneath those arrows? So 80%'s in the middle. Reese is right. 10%'s on either of these arrows. 10%'s underneath. That's just because 20% is total outside, and that leaves 10% left on like 20 divided by 2, 10. So what does that mean? This is right here. This is the what? Like what percent of area is below this? What percent of area is below that right there? What percent of area? I can't accentuate that enough. What percent of area is below that? 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 So below that line right there, if you go to this line and you were to go below it, what percent of area is below it? What percent of area is below that line? So you've got this line right here. You can see what's above it. That's what's above it. And then what's below it? So I see 10% is above it. 10% is above it, but what's below it? The whole curve adds up to 100%. So we can just add down the arrows if we want. 10% is above it. You're more than welcome to. See you, William. 10% is above it, but what's below it? So we would just add through the numbers right here. When we add through the numbers, what do we get? Because we've already figured out and we've labeled our full curve, so we know the area below this line would be what? And this is the z-score right here. Like this number represents the z-score, telling us this right here, this point is at 1.282. 1.282. So this is the, right here, this line. And then does anyone know what percent's below it? Because it relates to the question. So this point right here is at the 90th percentile. So what you'll notice here is that all of these numbers on the curve right now are what scores? All of these numbers, this is the standard normal curve. All of these numbers are what scores? All of these numbers. See you, Sam. Great job. Great job, Connor. All of these numbers are what scores? All of these numbers, and you're welcome for the Kahoot. You're welcome anytime. Oh, make sure to email me if you got first or second. All of these numbers are basically the standard deviations or the z-scores, right? Because they're just one standard deviation up, two standard deviations up, three standard deviations up. They're all z-scores. So think about this. We could also put the context for our curve. Let's go right here and put the context of our questions. And when we put the context, what do you notice? Here is where 80 would be at. Here's 90. Here's 100. And we're just going up a standard deviation each time. Your answer for this question must be between 90 to 100. So this answer we're about to get is going to be somewhere inside of here. Does anyone know what the answer would be for what is the score of the 90th percentile on the test? What is the score of the 90th percentile on the test? The score for the 90th percentile would be, we take the z-score down below, which was 1.2828, I think, 1.2826 maybe, 1.282. And then we times that by the standard deviation, and we add it to the mean. So the mean, which is y bar, plus the z-score times the standard deviation, which is equal to 80 plus 1.282 times the standard deviation of 10. And that equals to 92.82. And that's exactly where that line is at. So this is how a test question could look, where you have to solve it and know how to use z-scores and know how to use applet pictures. And we can confirm this answer by going back to the applet and simply just putting the context right here and going to 80 and 10, and we get 92.81, and it doesn't round it this time. I did 92.82, and that was my rounded answer here, 92.82, and there's more decimals right here because 1.2816, that's the additional decimals for the 80% confidence interval. I know I said 80%, but that's an 80% confidence interval for the 90th percentile. The other question was the finishing times of a local race. What percent of the... And then what's the end of it, AJ? Do you have the end of that question? The finishing times of a local race. What percent of people maybe had a finishing time? So let's take a look right here. What percent of runners had a finishing time faster than or finish time longer than 28 minutes. So what are we going to do right here for this question? We're going to draw our normal curve, and let's go ahead and take a look at it. I think we have another steer weight question after this. So here's our normal curve, and we go right here and we put 25 at the center, go up, 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 down, 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 and we go here to 28, and we're already there. So that's just one standard deviation above the mean. With it being one standard deviation, 68% is inside of the curve, 0 and 1 showing it's one standard deviation. And then what would be the answer right here for this one? So we could do below 28, above 28. But for this question right here, if we're looking at the area above this line, which I did a horrible job lining that up, but what percent of area would this be when we say the area above 28? The area above 28 is going to be, the area above 28 is going to be, great job, AJ. Yep. Is that making more sense for these ones right here? I don't know if that, does that help out with your question? I hate the color change, but I need to, Microsoft Word's crazy. It does. I have this issue, Connor, where Microsoft Word changes the pen colors. Do you see how I have the green pen selected and it's a light blue pen? The way I can fix this is I have to double select the pen a second time, and then because it like reverts to the old pen. So the way to fix it, I figured out like a workaround is to double select the pen, but I mean, fun, right? We got the other steer rate question right here, I believe. This one wants the percentiles. So where are we going to go for this? We're going to go to the David M. Lane applet. So the David M. Lane applet is where we can go. Link's going to appear on the screen. And we need to put in the mean and the standard deviation of 1186 and 74. 1186 and 74. 1186 and 74. Now for this one, we need to make sure that we are 1186 and 74, 1186 and 74. Make sure we get it right. Get it wrong and you get the question wrong. 1186 and 74. There we go. Last question. Yeah, that's got it. I don't understand how you got the 16%. Oh yeah, let me show that again real quick. Last question. Yeah, we'll do it one next. You got it. How did we get the 16% right here? So AJ, can you explain to Peyton right here how we, like, let's explain this. How are we getting this 16%? So here we're going to do this right here. So between -1 and 1 is what percent of area? Between -1 and 1 is, it's blue again. What is total outside? So AJ's using all the numbers right there. AJ's adding up these numbers, which you can do. So AJ's doing it this way, which is another way to solve it. And that is 16% right there. But if we have 68% inside, what is total outside? So Peyton, what is percent in? We just had a blink on the, sorry everybody, stream reconnect. If 68% is inside, what is total outside? So 68% inside, what is total outside? 68% inside, total outside is what? So you have 68% inside, then what's remaining outside? So 68% inside, what's total left outside? And the whole curve is 100%. So you're going to subtract 68 from 100. If 68 is inside, then what's 32? Great job, Peyton, right there. That's 20 points right there. And then so what are we doing to 32 to find one of the arrows? Notice how you just said 32 is left total outside. So one of these arrows is what of 32? Because it's a symmetric thing. So with it being symmetric, so as best I can draw. So due to the symmetry of the curve, we take the 32 and we do what to it? Because you said total, this is 32. Like total right here is 32 on the outside. Like totals up to 32. So then what do we do to the 32 to find each one of the arrows? Great job, Peyton, right there. You got it. That's it. Yeah, once you see it, you're like, oh, that's how we do it. And please ask the questions. You're like, hey, wait, how'd you do that? What's going on? I appreciate that. Because no, it makes, yes, I'm so proud of you right there. That's, no, I read all my reviews. And someone actually wrote in one of the reviews, Connor, they wrote, I know you're reading this right now, Brian, and I'll see you in class next semester, even though this is anonymous. And I've actually had people say who they are, like, hey, Brian, just so you know, this is so-and-so. And I'm like, oh my God. Oh, but one person wrote in the review, I emailed my professor and they never emailed back. This class was taught by a bunch of different professors and I never knew who to contact. And I was like, what if they were reviewing my class and they thought they were reviewing another class? Oh my God. Can I have that thrown out? Because there was one class where a few students didn't like me. I'm just kidding. But I was like, none of the classes I teach are taught by a ton of people. And I email people back, I swear. I'm sure I've forgotten to email someone back. That was the one student I didn't email back. And I found out the hard way. The area is shaded. What percent of adults have a body temperature higher than? Okay. So with this one right here, the area shaded looks something like this. And we are interested. Thank you, Connor. We are interested in this area right here. So I'm doing like a quicker solve on this one. Because there's the mean and standard deviation. Here's the mean. Here's the standard deviation going up 1 sigma, 2 sigma, 3 sigma. I'm doing for stairway problem and using it and still getting it wrong. What's your? We'll do that next page. You got it. What do you notice about this area right here, which is this? What do you notice? You're interested in the shaded region. What do you notice about this? What do you notice about this, AJ? And what do you think the answer is when you look at this and you say, okay, I'm interested in above this point right here. Like this is what you're interested in. This right here is the value right here. Color change pen. I don't like you. You're interested in the area above this point. And what do you notice about it? About this region over here? Like if I were to take this right here and just go over here with it, like maybe, maybe not. If I go wee. Wait. I'm gonna make it happen. Yes. Hashtag life goals right there. What do you notice about this? Like we have this area over here and this area over here. And what do you notice about these areas? What do you notice about them? We're interested in this one. What do you notice about that one? In total, those areas are 13%. But what do you notice about this one and this one right here? Any thoughts on these? What do you think about them? So we want to know this area right here. That's the area we're interested in above this point right here, which is right here. They're equivalent. So what do you think the answer would be if the total area is 13%? What do you think the area of this would be? And this is like how test questions might be. So what do you think the total area, right? Or what do you think the area of this might be? And I think, so that kind of, if they're equivalent, and we're interested in one of them, that's the big tip right there. So Peyton, which one are you? You said you're doing the first one. Tell me if you don't get it, AJ. Let me know, and we'll go back to it. With this right here, is this the one you're doing right here? There can be different orders to the question. So sometimes it's the first one, sometimes it's the second one. It randomizes the order. You said I'm doing the first steer weight table and using the interactive Z table and still getting it wrong. Can you go over that? What is your mean and what is your standard deviation? What is your mean and what is your standard deviation? So if you can tell me your mean and your standard deviation, I'll work one of your problems and you can check your work so you can make sure you're getting it right. And that way you can be like, okay, it is this one. Mm-hmm. So what are your numbers right here? What's your mean and what's your standard deviation? This is the mean, which is the center of the distribution. Good to see you here, Tyler. What is your mean and what is your standard deviation? Like mine, this is my mean. That's the center of the distribution, which means the average weight of steers is expected to be 1,186, or that's, I guess, population mean. So that's what we would observe on average. And then the standard deviation is 74, saying that the variation, thank you so much. There's the mean and the standard deviation. Okay, so with that mean and that standard deviation, we go over here to the applet and we go to the second button. That's very key right here. And we take the mean and we take the standard deviation. And here we go. And then we need to find things. Let's see what we're looking for. What percentile are you looking for? It says the weight representing the 38th percentile. So the weight representing the 38th percentile, what would you put in, or what does yours say? Yours wants the what percentile? So the 38th percentile is going to be somewhere over, at least for mine, 38th percentile is going to be down here on the left side. Make sure you do the left side right now, because, oh, that's not the left side. So that was the 62nd percentile. It's the same percentiles. So this is the 38th percentile right here. You have to make sure it's graphed this way because 38th percentile is below the mean. It's above the 16th percentile, which would be right here. So is this what you're getting right here? Is this the answer you're seeing? I have a tiny bit of water left. Almost no water. Is this what you're seeing right here? Connor was in the last class I had, or one of the last classes I had that were in person, 474. The fated semester last year. My gosh, Ray, you're past that now. I still haven't gotten a real haircut. Oh, nice. Yeah, that's what I thought it was. It seemed like you were doing everything properly, but this right here would be the 62nd percentile. And when you do the IQR, go between right here. Yeah, exam 1 for Stat 201, when everything just went exploded. It was like right before, and then I was so excited. It was like an early spring break and everything, and I was like, this is so awesome. Oh yeah. Oh yeah. Wasn't that it? And then people are like coughing in the background. No joke, Connor. No joke. I actually left the room because I was having a bit of a panic attack. Do you remember when we were doing that exam and I actually left the room? I actually went on a walk throughout the whole building for like 5-10 minutes or something. And so I was having a bit of a panic attack. I mean, I'm fine with just putting that out there. I think it's fine to talk about things we deal with in life. But people were coughing, people were like wheezing. I just left the room and I was like, am I doing the right thing? You know, I encouraged everyone to like, hey, if you feel sick or you're coughing, you can leave the room right now. We will give you another exam at another time. I will, we will work with you. We will do anything. And then I start hearing like a few coughings and stuff. And I'm just like freaking out. And I'm just like, yeah. So if you ever think Brian looks completely calm and composed, realize sometimes we're all kind of, trying to, I don't know. I mean, I hope I seemed calm and composed that night, but I think we were all, going through a lot in that moment. I have no idea. Yeah, I did. I can see that. Yeah, I can see that. We'll go back to the question here, AJ. Yeah, no, everyone was working really hard on it. Like we're all here to help each other, and I appreciate all the help. And I think sometimes look at me. Sometimes people are like, "Oh, you're doing fine, Brian. You're doing great." And it's like I don't know. Sometimes we have a hard time with it. Like, but I think. Oh no, we've gotten used to it. So things are getting more back to normal. That's good. So with this one right here, AJ, you want this area right here. Does that make sense? You're interested in this area. Does that make sense? This is the area you're interested in. What do you notice about the other area over there on the other side? It looks the what to this area. That area over there on the other side looks what to it? Oh, no. I'm sorry, Connor. That area on the other side looks the same exactly. So if we know the total area here is 0.13, like total, like both of these added together, like both of these areas is 0.13 added together, what do you think one of these areas is worth? Because we just want this area right here. We just want this area. And we know that both of them added together is 0.13. So what do you think one of these is worth? Like, we just want this area. Jeez. Well, and everything's all right now. Is it, Connor? I hope everything's all right now, like 100% again. And thank you for getting vaccinated. Thank you for, like, looking out for everyone. I'm hoping you're back to 100%. You're like, yep, fine now. Hoping to hear that. So we just want one of those. That's good. That's good. Yeah, my brother said he had a really bad headache. So, yep, AJ, you're getting it because it's half of it. You got it. Great job, AJ. I think we've got it now. We've worked on some good questions right here. Any other last questions before we head off? Great job, everyone. It was just like, why? Why? Don't worry, I've got no muscle on my arm, so they'll just put it. I can't be hurt. Just don't work out. That's the key to life. I'm kidding. Work out. Yeah, what's up? What question do you have? Feel free to ask, Connor. What questions? Here, I'll hop to space. Let's go to space. Oh, no worries. Hope everything's all right there, Sheets. Don't worry. It's recorded. I need to put in the timestamps. It was a big lecture today. Work on the assignments. Let me know if you have any questions. Big lecture today. So definitely have a nice day too, AJ. Thank you so much. Great work. So hope everything's all right, Sheets. The piano came today. Probably going to let it decontaminate a little bit. When mapping out a QQ plot, you could grasp a general idea on how the data might need to be transformed correctly. Yeah, you could. I mean, you can see extreme skew. Choose the correct graph of the z greater than 0.05. Yes. So Peyton, use the David M. Lane here. We'll take a look at that here in a second. I'll put the David M. Lane in the chat. David M. Lane in the chat. Find the percent of area to the right of z greater than 0.15. Yep. See if I'll check your work here in a second, Peyton. I think you can use the QQ plot to figure out the transformations. I'm going to pull up the applet right here. Are you doing some work on that? I think there's a bunch of packages that try. You're trying to transform for normality, right? Connor's actually talking about something we talked about today with the normal quantile plots or normal probability plots. So Peyton, what do you have as an answer? What do you have as an answer? Let's see what Peyton has. Are there not some packages that try transformations to fit normality? Because then you could see which ones. Good to hear that, Sheets. I'm glad to hear that. Yeah, and it's so busy. Like, I think, man, if I need to make a doctor's appointment, it's gonna be like, they'll be like, we can see you at 10. I'll be like, I have to teach. And they'll be like, tell your students time off. So do you have the David M. Lane open? See, I got this. I'm gonna help you out. Don't worry. Do you have the David M. Lane open? Ooh, Connor, send me what you have, and I'll take a look over it. You can do run a Shapiro-Wilk on it. You could run a bunch of transformations and run Shapiro-Wilk, or what's the other one? Anderson-Darling. Did they do it? So you want to go to you want to have 0, 1 in. I'll go over here and I'll show you. Let's check it out. Great work, Peyton. Okay. So remember the question is, you want to find the area above 0.55. What answer do you currently have? I currently have the wrong answer. What answer do you have, Peyton, right here? And when you get the answer right, your graphic will look like the graphic on the screen. So when you get the answer right, your graphic will look like the graphic on the screen. Yep, that's exactly it. That's a good question right there, Sheets. We did an example problem just a little while ago where we said like what it could look like. So this example problem we did. Yep. So this was like an example problem where you're giving information and then you have to find out the number. So you could find out the answer, but we were given the z-score in this problem. We had to turn it back into an observation for the 90th percentile. So there's definitely problems like this that could be on the test. So how's your graphic looking, Peyton? How's it looking? We will see. I don't think I have the mic screwed in all the way. Maybe I do. I don't know. I shouldn't try to change things lest I break something. That'd be very bad. I will see. So right now we're graphing above. Yes. Nice job. So here's a hint. Here's a big hint. You ready for this, Peyton? This is a hint for the question. So this is answer 1. So you just put in this right here. I wanted you to, like, if you got stuck, I wanted you to tell me. So that's the answer to 1, which you should see this, and that confirms your answer right there, and just put it in as a percentage then. And then the answer for number 2 is below. So this will graph below, like maybe it has like negative 1.2, or it has like 0.8, but that'll graph below. The answer to number 3 is going to be this one, where you go between two numbers. That's going to be the answer to number 3, where you go between two numbers. And then the last one is in terms of absolute value, where you go outside the absolute value, and then you get the answer here below. Does that make sense, Peyton? So this will be the answer to question 1, and like these numbers are not the numbers, but also know how to use this and read it and understand that it's going to graph the area above a z-score of 0.8. It's going to, or below. See, I don't even know how to use it. It's going to graph the area between z-scores of negative 0.5 to 1.2. It's going to graph the area outside of negative 1.8 and positive 1.8. Is this making some more sense on how to use it? The other version of it, you enter in the percentile. Peyton, great job. Thank you so much. Let's throw out some 20 points. Any other last questions here before we head off? I'm going to go back here in just a little bit. I'm going to eat some food and then put some timestamps. I forgot to do that today. You're welcome. Use the z-values in Math 323. Yep, z-scores are super important. If you can integrate the curve, you're doing even better. The graphical example helps out a lot. And Connor was mentioning this earlier that we use a lot of times. Whoops, I'm just going tiny. We go right here and do the Q norm and everything. So a lot of times if we want to find the percentiles, you might use MATLAB and stuff like that, but we go here to Q norm and there, that's the percentage, right? So this should return 0, right? Yay! And then if we go to the 84th percentile, we should get a little bit below 1, like 0.98, 0.99. If we go to the 97.5th percentile, we should get a little bit, 97th should be 1.9. This is going to get scary. You too, Connor. 1.9. I'm going to type this in. You ready? 1.95996. That's what the z-score is for this. There it is right there. Oh, I didn't know the last decimal. I got to learn more decimals on my 95% confidence interval. That's a 95% confidence interval because outside of it is 5%, 2.5 on either side. And yeah, so that's got it. Really great work here, everyone. And I think that's got it. Let's say goodbye. Let's put on the music, classic music. Well, with that, keep working hard. Well, thank you. I like memorizing numbers. People are like, z-score is 1.96. I'm like, it's 1.95996. And they're like, what is wrong with you? So anyways, we'll do more fun. We'll do more practice. Sheets, keep up the great work. I'll see everyone tomorrow. First week over, 1/3 done with the class. Middle of next week will be halfway done. End next week, 2/3 done. End of the next week, done with May term. Don't let this freak you out. Let it bring excitement and joy that our hard work and dedication is going to pay off. And keep working hard, stay focused, and ask me any questions if you have them. With that, I'll see everybody later. Bye for now. I too like memorization. Awesome, Sheets. Bye for now, everyone. Bye. I think it's a music thing. The memorization thing. I think it's a musician thing. Memorizing.